Great. Thank you, Andy. So I'm really excited about this topic. It's something that is kind of an interesting story. So baghouse.com, as many of you know who maybe are existing customers or have interacted with us, we focus on dust collection systems, which is a pretty niche piece of the overall industrial landscape. So for the last few years, since I've been with this company, we've looked at a lot of sensors and process control devices that apply specifically to dust collection systems. Things like differential pressure gauges, emissions and particulate monitoring and sensing, broken bag detectors, uh, vibration sensors for fans, things that are narrowly applied to our dust collection focus. But interesting, in the last few months, as we've got involved with Senzary, I have really had my eyes open to the fact that there's a whole new world now of connected sensors and IoT and all kinds of applications and options and opportunities derived from that apply to really the entire enterprise, from the dust collection system and the other industrial components to asset tracking, predictive maintenance, people monitoring, all kinds of stuff. So the focus of this webinar is not going to be on dust collection systems, although that's near and dear to my heart. Of course, that's what we do. But really, what Sensori is bringing, to the world is so much more than simply connecting sensors and making dashboards. It really is a whole new world with AI-driven tools and technologies that will certainly affect every business and site and enterprise that's operating today in ways that we're just starting to explore. So I'm super excited about this. I'd like to introduce both Eric Schummer, who's the founder and CEO of Senzary, and also a special guest today, which is Marlena Nickel, who is the Chief Strategy Officer of Senzary. And she'll tell us also a little bit of her perspective. So why don't we start off, Eric? Thank you for joining us, first of all, Eric and Marlena, to give the audience a sense of what we're talking about here, the scope and scale of IoT. The focus is boosting ROI with connected sensors and IoT. So what exactly does that mean? What type of projects or applications has Sensory done in this space to give folks a sense of, um, what does that mean? What do we apply this to? Can you give us a few examples to start?
Absolutely. Hi, good morning, everyone. Matt, thank you very much. Are you seeing the video?
Yes.
Okay, thanks. Don't want you to miss that. Um, yeah, thank you for the introduction. It's a pleasure to be here today, sharing some of our experience and providing hopefully some interesting advice for all those who are either doing it or planning on doing it, and hopefully we'll be able to collaborate in the future. As you were mentioning, we have had the opportunity over the course of the last couple of years to work on some very interesting projects across different verticals. We will learn more about that, but just to give you a quick rundown, one of our customers, for instance, is Fortune 500 in the utilities energy business called AES Corporation, sorry, for whom we pretty much have implemented our entire operating system for IoT for enterprise. And we are deploying this across 8 countries, 10 countries, and over 100 different plants. And that covers monitoring, for instance, of all data centers. And also we are working on predictive maintenance on energy generation with our very smart predictive maintenance technology. We have also implemented the LoRaWAN, which we'll talk more about that infrastructure, wireless long distance infrastructure across the plants, where we can cover like the whole plant with 1 or 2 radios very cost effectively. Other projects involve consumer manufacturing like Procter& Gamble, Ragasa for food or products. A lot of work surrounding predictive maintenance and correlations of operations and flows and trying to improve operations, definitely reduce downtime. We work very closely with one of your partners, IAC, International Accessories. With them, we are OEMing some of the, we're manufacturing or replacing some of the older control units for dust collection and backhouse management. So we have acquired in the past couple of years, I think, significant experience and knowledge on the cement, frac sand, and dust related type of environments. So regarding silos, regarding backhouse management, all these different modules that run the overall process of the cement business, and especially around backhouse management, dust control, conveyors, silos, uh, things like that. Another interesting customer would be like the Panama Canal, where we implemented our technologies from the Atlantic to the Pacific within just a couple weeks. And we were able to measure thousands of vessels as they crossed the Panama Canal. And in there, we were measuring their contributions to the emissions, to the pollution on sulfur emissions, which are theoretically governed by international regulations. And well, it turned out almost none of those vessels were complying with the regulations. And we discovered about $100 million opportunity for the Panama Canal in regards to how to deal with that. And finally, we have other types of customers, like in government, like we monitor the aquifers for the state of Indiana. We also perform full house activities, like in the Jacksonville International Airport, where we monitor air quality, we count the people on the restrooms, we do analytics, we do predictive maintenance on the baggage handling systems. So, I mean, the point is that our applications and technologies and the breadth and wealth of our engineering expertise allows us to cover multiple different verticals and within those cover different stakeholders, whether it's environmentals, reliability, predictive maintenance, operations, supply chain, tracking. We're implementing for the oil company in Mexico our combination of our employee tracking solution along with environmentals because of closed refineries so that we can make the proper alarms and events when the environmentals become dangerous to the workers. And also on the offshore supply vessels and offshore platforms. So all the activities in support of these offshore platforms is being managed by our platform as well on services.
Wonderful. That's so it's a lot more than dust collection systems.
Very
There's
much more.
yeah,
That's why we call it an
absolutely.
operating system, and we'll talk more about that. But I would like to take
Yes.
the opportunity to introduce you to my good friend and partner, Marlena, which actually the story with Marlena is that she was my customer. And she worked at Shell Corporation until recently. And well, I don't know if she liked us or she liked our products better, but the point is she came on board. She's now a full-time partner and management at Senzary, and I want her to give her own side of the spiel. So back to you, Marlena.
Sure. Thank you, Eric. So, yeah, Marlena Nickel. And so I joined Sensory earlier this year after leaving my career of Shell of almost 28 years. So, took a retirement, and then Eric convinced me to join forces with him. And so, yeah, I thought it would be a great opportunity. So, how I Shell got involved with Senzary is we were looking at different technologies for people tracking for a large turnaround at one of our facilities. And so asset and people, particularly people tracking, it's a really challenging technology to look at. It's not cookie cutter because you're involving, people going inside of buildings and then outside on a complex. So key to us, of course, was EX or ATEX or explosion-proof devices. That's really key on any oil and gas facility. And, also during a turnaround, you have lots of contractors coming on and off site. So they may not know procedures or do not enter zones. So with asset people and asset tracking, you would create geofences. So reached out to Eric through another mutual vendor that we were investigating. And in my role in Shell, I was the IoT technology manager. So I actually established Shell's IoT strategy and roadmap and de-risk technologies of which LoRaWAN was one of the technologies that we saw had great capability and penetration through facilities like with lots of steel and concrete. And also that it was a safe and secure type of technology. So that kind of led us down the pathway. And then back to the people tracking challenge. So again, like if you use your cell phone, you know that if you're using Google Maps or something like that, it won't work inside of a building. So many different technologies come into play, and Eric had the keys to know exactly what we needed and how to combine all these technologies to work together both indoors and outdoors and in difficult sites and with, deploying thousands of sensors. So that's, and then I guess the other key thing about Senzary, what really impressed me is that, um, Eric's able to deploy a solution within weeks instead of months and months and months. And so that is really, I think, one of the key features that Senzary provides to their customers. And so, so we were kicking off a POC and did some work there, but basically, yeah, so just happy to join forces with Eric, and the potential is huge, as you saw with the different solutions that Eric holds in his portfolio. So thank you.
Beautiful. Thank you, Marlena. It's great to have you here as well. So, Eric, I've been around long enough to have seen a lot of different technologies come and, spread through the industry, automation, various types of communication systems. IoT is one that I have been hearing about for many years, even as in the early 2000s, IoT, connected sensors, the promise of the Internet of Things, the Internet of Everything. Some of those technologies panned out, and we see them all over, certain automation, robotics, things like that. IoT always seemed like one that never quite lived up to the promises, in decades past. I know that now we have a few, technological breakthroughs that are really changing that story. So my question to you is, why is IoT important, and why now specifically versus maybe 5, 10 years ago?
Wow, that's a long question, but a very interesting one. Well, they say that timing is everything. And one of the things that as an entrepreneur and technologist, I have learned to try to avoid is to be too early. Back in, I don't know, 2002 or 3, we did the first intranet for Black & Decker at the time, convincing IT guys that they need to talk to the business people, convincing business people that would not need to speak to the IT guys. And that was kind of the hook back then, right? But what bothers me is that 20, 25 years later, we continue to have companies that do not use intranets. So sometimes it's not the lack of the technology. I think that's a big part of the equation. I'll get back to that. But it's also the attitude and the management attitude towards technology and the existence or the lack of champions within these companies to make these things happen. I can understand that sometimes innovation sounds like a bad word, and it is potentially if it's not properly managed. You cannot innovate just for the sake of it. You need to be solving a problem. You need to be looking for an outcome. You need to be thinking of what's next after that, which is what I can see a lot of our customers have not thought this thing through. They look at the technology, they want to try it, but there isn't really, in most cases, like a real plan. So why now? I think we are in a moment, actually, with the advent of AI, I believe this whole conversation has been greatly accelerated in ways that are incredible. And we are leveraging a lot of it as quickly as we can, but in chunks that make sense within the context of what we're solving for the customers. But I would summarize that probably in terms of real time. I think real time for an industry, it's hugely important. It's the difference between an employee having, an accident and not being taken care of in proper time. It means a formula and a mix in a product that goes bad altogether. It means I'm going to get fined because I did not resolve the problem of the dust at the time that it was necessary, or I was not able to anticipate that. I mean, we have such amazing tools for predictive maintenance, and the return on investments are literally sometimes days for some of the customers we have. So why would you not, right? The second thing is that now we have the advent of another layer of innovations. For instance, in the area of telecommunications, we now have all this plethora of sensors around the LoRaWAN protocol, as an example, where we have, I don't know, dozens or hundreds of vendors and thousands of sensors, which are all interoperable now. That was not the case a few years ago. Also, they are wireless, battery operated. What does it mean? Installations can take place hours or minutes instead of cabling and planning and stopping plants and stuff like that. We put our sensors with magnetic magnets into the case of the engine, and you're monitoring right now. So all of that, it's super important. Air quality, environmentals, leaking, vibrations, pressures, levels, flows, lasers, radars, all of that stuff is now available, including ATEX explosive rated sensors too. So the sensors have extraordinary quality now, industrial quality. The wireless infrastructure is there to support all this with the necessary encryption security layers that make it enterprise viable. And then companies like ours, which are looking at all this and building these type of operating systems that are probably new to the industry, which help companies add this piece of architecture to their operating environments and help them control things a lot quicker, a lot better, interacting with multiple stakeholders like you do with a SharePoint or like you do with your emails, right? So we're just bringing all that to the industrial scene with security, with process, with engineering, and we're being rewarded by very happy customers.
Wonderful. I love it. Sorry, it looks like we skipped a few slides there, Andy. So, you talked about this a little bit, what was traditionally seen as barriers and issues that are now really not because of the advent of AI, the high quality sensors, the ability to just like all of a sudden going from a telephone to an iPhone in your hand. Now we have AI powered devices, plug and play, very well designed and engineered, innovative, highly secured LoRaWAN gateways and communication protocols. That's all there now. So that is a great answer to the why now. So let's talk a little bit about some of the stumbling blocks. Now, we have all this technology, the capabilities. Still, oftentimes we will see customers that want to implement IoT. I myself, in previous, companies, have seen the digital transformation attempted, and it seems like it gets done piecemeal and never quite has, in my experience, on a customer side, it doesn't quite pan out how you want. So what are some of those stumbling blocks and barriers that you typically will see companies struggle to implement IoT?
That's a great question, and it would surprise people to learn that based on sources and different reports that we have looked into, a significant amount, and I'm talking 60-70% of the IoT projects in the past few years are failures. And the reason for that, and actually true story, when we started working with AES, the first thing the digital director tells me, are you aware that you're like the third company that we bring to do this? And I said, well, this is going to be the last one. And it was. And the reasons are, for the most part, first of all, there's continued to be too many silos within the company, and there is a tremendous amount of lack of communication. Like we were at one of these cement companies, and we implemented for the reliability manager dual pressure sensors on the baghouses for monitoring the filters and making sure that they were controlled. But more importantly, in this case, it was because we were automating his EPA reporting tool. So he used our stuff to do that automatically from his desk instead of having to go measure at 100 degrees, and all white. And I looked like a Mad Max when I was there, all dusted. So I had to go there for whatever the reason. And I'm escorted by these two guys throughout that huge plant, up and down silos, staircases, etc. And they look at me looking at my phone and say, "Well, what are you doing?" I said, "Well, I mean, I'm looking at these dual pressure sensors here. Why do we need to come here 4 times a day?" I said, "Well, because your boss doesn't talk to the other boss." And in fact, it was the case. So the moment we had that meeting, a week later, that activity became now more a wider activity across other stakeholders that were not even aware of this project. So that my first advice is get a group of people and create a group of users. The second thing is a lot of those pilots do not scale. You will test this technology, somebody came through your door, you kind of liked it, you're going to give it a go. But more often than not, they will not scale. They will not be able to incorporate other types of sensors. They will not be able to incorporate other locations. They will not have necessarily the security requirements to go through your security teams, and so on and so on and so on. So make sure that whichever partner you choose have the ability to support you, not only at the beginning, but throughout and as you grow with it. The other thing is, what also happens is that, let's say you want to do a pilot for predictive maintenance or dual pressures or reliability, but it becomes an IT project. It stops being a dual pressure project. And then we spend weeks and weeks, getting to the IT folks. Like, we have a strategy that has worked very well for that. We still work with IT, especially around security and things like that. But we provide mobile gateways that completely bypass the company's network, initially at least, so that we can focus on the pilot at hand and make it quick, weeks, like you were saying, Marilena was saying, as opposed to months. And as we do that, and we do this because we are not doing a pilot. We know our stuff works. We know everything works. So pilots usually, more than not, become production. But then 5 minutes later is, okay, what else can we do? And that's when you have to start working at a corporate level. Sometimes they can see, because we get some executives look at what we do, and then they understand that they can start benchmarking multiple locations, that they can start changing the way they do business. Because if I have predictive maintenance 24/7 now across 100 motors, and I can do that across 10 locations, well, I definitely can find efficiencies on the resources that I used to use for this type of activity, and now I can do that from the air conditioning for all the locations. That's a game changer. So that game changing process needs to come along with change management, documentation, training, and a lot of discussions in what I call digital transformation. Because what we do, IoT, the way we do IoT, it's framed within the corporate initiatives of digital transformation. It's a big topic, and if we have time, we'll talk more about the 4 floors, like I've been saying before, where the first floor would be the hardware, the sensors, and all that stuff. The second floor is like the infrastructure, the wireless infrastructure, and the security and management of all those devices. Like when you have phones in your office, you need permission to connect to the Wi-Fi network. Well, with IoT, it needs to be the same. And then the third floor would be more like the operating system, where we control in real time all this data coming in from multiple protocols. It doesn't have to be wireless only. We also do BACnet, we do MQTT, Modbus, we have analog, digital. So we can connect to pretty much anything that you want to make visible into your dashboards or into your screens. We connect to everything that you want to control. We can do fusion of data that was previously not combined into something that you can make sense of in a system, for instance, right? So integration comes later. The integration comes after you have been able to being exposed to the technology, you have been exposed to the value of the process and the technology. You can gain an appreciation for how quickly this was done, how effective it is. And then we start integrating with other applications on the third floor, such as IT applications, OT applications, and enterprise applications. So we speak to all the corporate floors all at the same time. You can connect to a Snowflake, a Power BI, or whatever corporate purchased in real estate for data analytics. But then we can also talk to a SCADA system, or we can talk to an Oracle or a SAP, and so forth. So IoT, it's the internet of real time. IoT is the internet of let's get the whole thing connected and a unified, orchestrated manner of data flows across the corporation. And that's where you start really seeing the values.
That's a beautiful segue to the next question, or the next topic really is, so your approach is different in that, as you said, you have a system in place. You already have IoT logic. You've got it all built. You don't need to go start by plugging into facility A's IT system, see how it works, then later change. And it's all there. It's a standalone, off the shelf, if you will, IoT package. Can you share a little bit of the details? I know we have a graphic up next. What is it? What does IoT the right way look like? If we can look at the whole picture, and see the elements here that essentially Senzary as a package ready to deploy, how you can do this in 2 to 4 weeks versus, months and months for pilot scale applications.
That's good. Thank you. The first thing, which it's pretty important, is that we are agnostic. What that means is that, like everybody, we end up having our favorites because experience gives you, better experiences with some vendors and others. And it's not just the technology, the quality of the products, the support, the facility to work with it, and so forth. So there's a scorecard for that. We work with people from China, Taiwan, Australia, Germany, Italy, Poland, et cetera, et cetera, et cetera. And the second thing is the 80-20 rule. We have invested tremendous amount of time and money in building the 80%. What I mean by that is that we have, at this point, I think, 80% of what anyone would want. The other 20% is when, once we are in business together, we start customizing this thing for your operation in particular. It might be a customized existing set of dashboards, as an example. It might be some specific integrations with particular applications via APIs or via other means, MQTT, et cetera, et cetera. Or it could be customization, new code, new software that you need to incorporate into what you want. All of that is now so possible. I remember when we used to work with applications back 20 years ago, where the applications would not talk to themselves. So then voice XML came up, SOAP came up, XML came up, and then all of these protocols came up that helped the world move into the industrial revolution of the 20th century, right? So I think we are experiencing this multiplied a la X with all this new technology and integration capabilities that we have and it's about a process, and it's about having the right toy to play the right game. I like to think that this is like an orchestra where you can have a saxophone or a trumpet, but if you don't know how to play a violin, we all know how it sounds. I think we have learned to play nice music, great music with the orchestra that we have, which is composed of our technology, sensors, and all of that stuff, right? So those two are very important, and they are key to being able to deploy very quickly, these different things. In addition to that, we also have the ability to deploy on the cloud, which is super quick, but we can do hybrid and we can do on-premise. And on-premise can be like the whole thing can be on-premise, because there's many companies that will not have it in any other way. Or we can start different type of pilots on the cloud, which is super secure. We work with governments, airports, Fortune 500, so we have been grilled about security more than once, guaranteed. And but then our technologies only speak from the inside to the outside. We we at no time enter into the network of the clients, even if we're connected through the network of the clients. All the communications go from the inside to the outside. That's pretty important. So I think that in addition to that, the cherry to the cake is you have the ability to pick your pain point. Is your pain point maintenance? Is operations? Is it tracking assets that get lost, like in the case of Shell, for instance, where subcontractors confused equipment that was not theirs for theirs, and also environmentals. There's so much regulations, like there's new regulations for Misha for silica, for instance. How quickly can you react to that? How quickly can you be in compliance, and how much is it going to cost you? So we have very simple, easy to implement solutions for all those different pain points. So pick your poison, and then we can grow horizontally, we can grow vertically, and that's the key to this. It's a Lego. You can add more and more and more, and all of them are almost done. So you just need to tell us how you want it to look like and how you want it to interact with your own people, alarms, events, notifications, integrations, and then you're in business.
That's a great summary, Eric. And that, I mean, most companies, the larger the company, the more pain points and different levels or different floors, as you say, they're going to have. And oftentimes, you start with the solution for a floor one pain point, which is I need to do predictive maintenance for my fan motors. And then you design a solution for that, or the company designs a solution, and then they have another pain point, which is we need to track our vehicles en route, from suppliers to our facilities, and another solution is designed for that. But really, what I'm hearing is like what's possible now is there's one solution. You just have to integrate it or basically plug into it whatever your pain point is. You don't have to redesign all of these different systems. It's all there. It's one system. Um, and as the awareness throughout the organization grows about the capabilities, or it's like, hey, we have this IoT thing now. It's working great at facility A. They do emissions, they do predictive maintenance. What else can we do? Scalability is key. Some of the customers that you mentioned, some of ours are Fortune 500s. They have hundreds of facilities throughout multiple countries. Sometimes it's super important to be able to deploy a tool or an operating system that can be scalable throughout the organization. So that's really amazing. Um, I
Yeah,
think
and I just want to add, because what you're saying is true, that also when you think of IoT, 99% of the people will think of the sensor. What most people don't pay much attention to or underestimate the complexities is that we're deploying thousands of sensors across countries, across multiple plants. There needs to be an embedded onboarding and project management capability within the process and the product. So our product is not just geared towards visibility or measuring things. It's geared on the left, so to speak, towards the beginning of it, which is before it was implemented, and dealing with all the issues associated with all those implementations, and minimizing the amount of tickets or the why is this happening, or the inability. I mean, I have a customer like AIC, and they have a customer which is a cement company or something. Then they are going to do an installation, and they have on whatever city as a different type of electrical company that will go there doing the installation of the sensors. And then they have an electrician who has never heard the word IoT, and he has to install an analog sensor and then see if that is connected to our platform in the back. We are really trying to shortcut all this into very, very simple ways to get all these processes running super efficiently.
Yeah, that's super important as well. I wanted to just mention or ask one question about sensors. You mentioned, so you've got a toolkit, if you will, of thousands of sensors. Customers may have their own existing sensors. We've
Yes.
historically sold and used all kinds of sensors. There's many high quality sensors out there for doing particulate monitoring, things like that. To what extent does the customer need to replace their sensors, or how does that plug and play with your IoT logic and Sensory's implementations?
Not at all. Actually, I love cooking, and one of the things I enjoy cooking is what do I have available and one beautiful dish can I make with what I have on the kitchen. So I hope my wife will attest to that. But the thing is, we have sensors which are now wireless, which is great. We also have a great variety of nodes, as I call them, to separate or to make that distinction, where we can connect multiple protocols. We have nodes that have like Modbus, which is a typical industrial communication protocol for like PLCs and things like that. So they are Modbus servers or Modbus client slaves on the right side to write or read from these devices, and then they turn around and immediately convert all of that into wireless. We're doing that right now, for instance, in Mexico with H2S sensors that were installed there, God knows when. So we're connected to them via RS-485, along with our wireless H2 sensors that we added to the mix, right? So all the typical industrial protocols are like RS-485, analog, digital, for alarms and events and pulses. We can read meters, we can read pulse meters, we can have different channels, like 8 of this, 4 of that, 2 of this, 2 of that. So the entire gamut of industrial, serial, and other communications are very easy to integrate into this whole mix. And I think that's a very important comment you're making, because obviously it's important to be able to use what they already have before you start adding stuff, you know? Needless to say, you will have people like, because there's another issue with that different, which is like you have maybe a reliability manager and he needs to get a pressure, let's say, but it's very hard for him to get that from the SCADA or from whatever other system, because they cannot customize it or modify it to give that person that information he needs or she. So we layer up our sensors, even if there's duplication, because they're serving a different purpose, or it's convenient for some other reason.
That makes perfect sense to me. Beautiful. So I go ahead and go to the next slide, Andy. And Eric, I had teed up some visuals of the dashboard, a couple example dashboards that we can pull up next that are on the next couple slides. But I wanted to kind of summarize the conversation
Yeah.
somewhat here and say, we've talked about a lot of things, scalability, security, real-time capability, the kind of elephant in the room that's AI driving everything,
Yes.
on both the sensory side and the dashboards and the data and all of it. So can you kind of give us a closing statement, if you will, on why is this a game changer? What is Senzary bringing to our customers and their enterprises, that's different?
Your life before Windows or Excel or Word existed was different. Your life before the cell phone was there was different. So I think we are about to experience a similar type of event, of tectonic type event, that there is no excuse now. You just don't have any excuse anymore. It doesn't cost that much. It's easy to implement. It is wireless and plug and play. It is industrial quality, explosive rated. Anything you can think of that you want to measure, anything can be done and more. Not only that, you can do things in a different way. When you wanted to know if a cabinet was open, you would have a mechanical way. Now I can even put a light sensor that will tell me if the light changed, meaning the thing was open. We're measuring distance to the floor on tires with radars, mini radars, which will tell us the wear and tear of the tires. So we're being able to measure new things in new ways that was not even possible before, right? So the game-changing portion of this is that it's all blended, integrated, ready to use. So you have a digital twin with all the infrastructure required to do this thing. It can scale horizontally, vertically across the entire corporation, and it's super cost effective. So my final question is, why are you not doing this?
That's a great question. That the cost effective and the plug and play piece is just huge to me because yeah, you can get a pilot up and running for next to nothing. It's not a huge CapEx budget. So yeah, there's so many opportunities. It's amazing. So Andy, if you don't mind, go to the next slide. I wanted to put these screenshots in here, just the example dashboards to give some folks that are listening who may be on like the operations side, like what, and then thinking, what does this look like? What is an ROI, or sorry, what does an IoT uh, system do for me? What am I getting here? So, these folks all have SCADA systems, they'll have an HMI in the control room, that kind of thing. Walk us through this slide and the next one, maybe, what are we seeing here as examples of your systems in action?
Sure. But Matt, you mentioned something in the past slide, and I would like to address that. I don't know if you want it right now. It's regarding
Go for
AI
it.
and the impact of AI into what we're doing and for the customers. I had this little epiphany yesterday watching the CEO of NVIDIA talking, and it reminded me the day where before we had actual browsers to browse the internet. There was internet before we humans were able to browse the internet. It was a network that allowed machines to talk to machines back then before we were able to interact with it. What just happened 2 years ago and has exploded this year is exactly the same. It's the fact that now we humans can interact with the AI ourselves. And what we are doing, it's also multi-layered when it comes to AI. Why? Because we have AI-enabled sensors, like the ones you're looking at on the screen right now, which I'll explain. And then there is AI-driven processes, which is processes that are monitored or controlled by AI agents. And then there is the AI, there's a new type of AI which allows you to integrate that machine learning computer, to give it a name, with our IoT platforms. So what that means is that now it's super easy to say, hey, what is the maximum pressure of my 12 bathhouses? And when was the last time that they flushed? And it will just go there and pick the answers for you. That's the number one important thing. The number two important thing is that in the near future, fixed UI screens are no longer necessary because this thing will be able to develop UI screens for you on the fly pertaining to your questions. We are doing a lot of this now, and I'm shocked, honestly, about the things that we're doing. I cannot believe them sometimes, In a matter of hours, we created for Procter & Gamble a complete solution that was able to go into the sensors, which were AI enabled, to further find correlations between multiple systems and understand new things about the entire system that we were not able to see altogether, except for what this AI thing was doing for us. So we are out there for blood, in terms of the gainings for the enterprise. But that's good, great. But you need to do the first things first. You cannot have AI when you don't have data. You cannot have data if you're not sensing or getting that data. So, it's a process and it begins with the beginning, but there's a journey. We know what the journey looks like, and we can help you go through the entire journey. That was kind of my comment. However, here, what you see, it's a very simple interpretation that works for almost anybody, which is you may have multiple entities because a lot of our customers work in different countries or are composed of multiple different companies. So our smart industry begins with the corporation, so to speak, but then it follows with companies. That way, for instance, we have companies that pay budgetarily from different entities. So they all share the same central solution, but it's paid by everyone individually, for instance, right? Or different currencies or different countries, different people. There is horizontal authentications, there's vertical authentications throughout the companies. So then what follows next is typical like locations, but then you have like areas and you have systems and you have assets and then you have sensors. So what we're doing here is very simply, very quickly, we don't care if you already have a digital twin. We don't care if you have a maintenance system. We don't care if you have a competitive platform. We have a niche in each one of those scenarios, okay? But even if you can use this as your own operating system for this digital twin stuff, but also you can use that to mirror or bridge whatever other tools and technologies you may have, so we can all speak the same language. That is equally important. So we can drill down all the way to the machine on the right, on the top, on the bottom, where you can see now colors, movement, icons, visuals. But this is 3 predictive maintenance sensors looking into a glycol pump on a 300 megawatt plant, right? And it's kind of the end of the road where everything that had to happen happened. But then along with this, you may have supply chain, you may have fleet management, you may have asset tracking, asset lifecycle management, order supply, production, and all kinds of other information. So you can, from here, you set up your digital twin with maps, floor maps, pictures, videos, training tools, documentation. So it's really a complete system for the operation of something.
Beautiful. Yeah, what you said something there that really stuck out, which was, in the next couple of years, the need for all these dashboards will disappear because you can simply ask the questions that you want the answers to the AI, and it will show you what you need and give you the answers you need. That's incredible. I 100% believe that to be the case because just looking at my own usage of AI, I've got ChatGPT and Perplexity open on my computer right now. In the matter of almost no time, they've become so integrated into our lives and especially in business. I'm just really, I don't know what the future exactly will look like. I think you have a better idea, just as one example, why have all these dashboards when you can have the AI show you what it needs? That's incredible. And I can't wait to see that as well. Here's another example of a dashboard. Looks pretty familiar for a control room type of data, right? You want to show us what that might be? Looks like some time series data for a machine or something.
Yeah, we brought this up because I really love this one because this is predictive maintenance. But this is not just like, let's get vibrations and ultrasound. But first of all, we can get ultrasounds too, not just vibrations. But it combines a whole bunch of data and it actually looks into the ISOs and tells you what the root cause, what the symptoms are, and what the possible root causes of the problems are. Way, way, way before you will ever know this in any other way. So the moment one of the bearing balls of a bearing case starts to act up, we see that immediately. So the amount of money this dashboard can send you, it's inordinate. Downtime, Friday night emergencies, gone. On plant maintenance, gone. Maintenance on equipment that did not need it, gone. So just start stacking up the money. This thing also has some extremely advanced technologies, like for instance, but this is maybe too technical, but in this type of predictive maintenance and the rotational environments, we have things like vibration analytics and ultrasound analytics by way of what is called the Fourier transformations, which is like a three-dimensional way of looking at time, frequencies, and amplitudes. So this thing already comes with it. So I call it the X-rays. So we can literally go in there from the air conditioning and monitoring from my house, something that it's down in Colombia or Timbuktu, and I can see all that is happening, and I can instruct the sensor to, like, you know what, give me 20 of these. So it will just go there, do the thing, you get back, and now you're looking. So we support customers remotely on predictive maintenance now. So we can combine ourselves as part of the team that helps companies understand the health of their equipment, for instance. And like I said, the early capability to detect and be able to advertise eventual future failures, it's invaluable. So here in the screen, we are telling the future.
Beautiful. Yeah, that's right in line with our, boosting ROI with smart sensors and industrial IoT. You want your ROI? How about predictive analytics, like you said, that tell you weeks before a failure? So that's resonates with me as the dust collection guy because it's right in line with what we deal with every day. Fan motors, airflows, things like that. But then you pile on top of that all of the floor two, three, and four issues and concerns and pain points, and it's all in the same system. So quite amazing. Andy, go to the next slide here, and let's wrap up the formal presentation. We do have some Q&A that for a few minutes that we'll go through with Eric, but basically, where do I go from here? So, this has been a really educational process for me, and I appreciate Eric and Marlena you letting us do this because every time we talk, I learn a lot more. We're proud to partner with Senzary. As I said early, we do dust collection systems and generally speaking, industrial equipment, but there's so much more to this. And, customers at all different types of levels and plant types and locations in the world and now have the ability to do really amazing things and save a lot of money, save a lot of compliance headaches, all kinds of amazing things. So I appreciate the opportunity to do this with you, Eric, and be involved. For those that are in the audience, wondering, is this for me? What do we do? Can we set up a consultation? Certainly you can. Send an email to our info@baghouse.com email address and we will coordinate, with between Baghouse and Senzary, and we'll talk to you about your project, figure out what your pain points are, put together a timeline, and walk you through the process. Eric, do you have anything you want to add to that as far as what people can expect if they reach out and are looking for guidance?
Well, first of all, I think we are very grounded in the way we look at this. We're not, out there to sell stuff. We really are passionate about solving problems. And I think we have put our money where our mouth is in terms of building something uh, that you can use tomorrow morning, literally, and then working with you hand in hand to make it better for you, for the client, for the problems. And so I think that's the number one driver that governs uh, the spirit with which I'm trying to build this company. And I think that uh, technology, consulting, and engineering need to be together to solve problems, innovating where it makes sense, not innovating where it doesn't make sense, and being very practical about how do we go about that. I'm known to tell the customers we won't do that, and because if it doesn't make sense, we just won't do it. But there is so much growth potential for most of the companies that we talk to and we speak, and there's so much learning that is involved, and having a company that can take you through the learning and share with you along the way and train your different people at different areas of the company about different topics. It sounds easy. It's not. It's something we've learned to do, and I think we're doing it basically well.
Beautiful. Yeah, thank you, Eric, for that. Andy, do you want to bring up or do you want to feed us the Q&A questions or how do you want to handle that here?
Absolutely, yes. No, no problem. I have here a list. Let me take a look at it. So the first question we have from one of our attendees is, are there software tools for predicting possible failures in IoT networks?
We just saw one of them, and there's several. So the answer is yes, and it's actually one of the main drivers that most of the customers are looking for is predictive maintenance, and it depends on the type of equipment and machine, because obviously we think in terms of vibratory equipment, rotational equipment. So it could be conveyor belts, it can be elevators, it can be pumps and motors, it can be kilns, it can be different type of equipment. So there's different ways to address each one. Normally, you think of uh, like air quality, for instance. I can smell diesel as an example, which means I may have a leak in the generator, which we're not looking at, right? We can see different, we measure over 20 different gases. We sense inclinations, tilt, vibrations, pressures. We can see metal particles in oil. So I mean, the combination of items can apply to different type of engines, and then the analytics of those data points over time can easily can help customers understand the most important part of predictive maintenance, I think, which is the degradation of a system. You can see how a system degrades, and that's where you can start making decisions, manual or automated, on what you want to do with that.
Can
Interesting.
I add a,
Mm.
a question to kind of follow up on that, Eric? So
Sure.
I don't know if this is what he was asking. I think you answered his question, but my question is the system itself, the sensors, the gateways, how do you maintain uptime or identify if there's a fault, or is there predictive maintenance for the predictive maintenance system, is what I'm
Okay, I
saying?
get the point. Well,
Yeah.
actually, this is an interesting question, and one of the things I love about LoRaWAN is that it's what I call a service-enabled protocol. It's not just a communication tool to have gateways and sensors transmit, which we do over like 900 megahertz. It's frequency hopping to start with, but our platform in the second floor I mentioned before, it's monitoring every single packet in real time, and it's negotiating between sensors and gateways 24 by 7, based on distance, based on noise, based on quality, based on signals. The sensors themselves, in the firmware of the sensors, there is a lot of strategies that are also governed by the LoRaWAN protocol regarding like rejoining the network, for instance. Oh, I haven't seen the gateway for 4 hours. Let me try to rejoin. And then it starts the process again. And we have connectivity back to the sensors so we can actually talk to them within certain windows of opportunity. Sensors are very oriented towards saving battery because they need to last several years. So we're very cognizant. Transmissions have less than 1 second because the payloads are pretty small. We decode and expand all those payloads in our platforms. So it's extremely efficient communication-wise. We have more than one gateways, and then our platform selects the best gateway for that particular transmission. And this is transmission by transmission. And then we have AI tools on our end, which are monitoring the count of packets, if they're missing packets, if the signals are degrading over time, a whole bunch of things that we have already identified as the usual culprits of problems, starting with the fact that maybe somebody disconnected the gateway, which happens too, right?
Got it. Thank you, Eric.
So the next
All right.
question we have in one of our attendees, he's talking in the setting of a concrete mix plant. They want to reduce dust in the process, and they are asking about the sensors that measure dust and noise.
Dust and noise. Dust, and actually there's a limitation that we learned in a recent seminar we did in Texas with these new silica regulations, which I think there is no escape for it. And what I mean is that our dust sensors are monitoring both particle counts and particle mass. And those particle counts and mass are measured in different scales, which are mostly based on human health. So we have very, very fine particle measurements for data centers, like 0.0 ppms, 0.01 ppms. But internationally, and even the US regulations mostly call for 2.5 and 10 ppms, which are the size of particles that will go into your lungs, below those sizes. Then we have the particle mass concentration per cubic meter. But they will measure dust in general with scattered lasers that are like beneath the sensors, which are, small in general, very small, very portable, and you can place them in different places. And I think that that's kind of what it does. The other part of the question was, he mentioned dust and
let me see, and noise.
Noise. Yeah.
noise. Noise is also interesting because noise can be measured in, noise is pressure transmitted over the air. Now, noise, we humans hear between 20 and I think it's 20,000 hertz. So we can see noise from some sensors, like we have air quality sensors that will give you noise as in decibels, which is the root square, the root mean square of all the noise that is being heard by the sensor. We have all the sensors that we're using, like in airports, for instance, where we have multiple frequencies of noise. So we can see noise just like we do ultrasounds on the predictive maintenance. We see sounds that are ultrasounds from 0 to like 80,000 hertz. So we can easily see the signatures of the equipment. So there is sound on the audible side of things because of regulations regarding the sound that workers should not be exposed to for more than X amount of time. And then there is sound, as in ultrasound, which is what you want on the conveyor belts and the motors running your conveyor belts and the concrete plant to do predictive maintenance on those motors. So sound and sound, right? I hope that answered the question.
Yeah, absolutely.
I'm going to chip in something too. Being at a cement plant, a dusty cement plant is an environment that I'm very familiar with. This is dust collection site, right? So I would
Yeah,
say it might be worth having someone like us come out and look at your dust collection systems overall to figure out if your systems are sized appropriately, the hood design and capture velocities are all good. Cover the basics, kind of the dust collection 101. And then the IoT, the sensors, the monitoring will help, once you cover those bases, then you will benefit, I think, a lot more from the sensing, predictive maintenance, all that stuff. Once you've eliminated the big issue, whatever's causing the dust all over your site, it might just be that your dust collector is not being maintained properly or your fan
exactly.
is undersized, something like that. So
Or the
the
filters
basic
are
stuff,
broken, but you're not
yeah,
monitoring that.
right.
That makes sense. The next question is, do these type of sensors work in extreme industrial conditions, especially with heat and dust?
100% yes. They're protected electronics, IP67, which means they're impervious to water, air, pollution, etc. We have sensors in the steel industry doing 400 and 500 degrees Celsius and Fahrenheit. Yes, the answer is absolutely yes.
Awesome. Yeah. All right. I think that's it. If you don't have anything else to add, Matt,
I don't. I just want to one more time say thank you to Eric and to Marlena and you as well, Andy, for spearheading and setting this up. It's an amazing, interesting topic. I think it's going to only gain in importance as time goes on, as these tools become omnipresent in our lives. And I think Senzary is really at the leading edge of making this reality in industry. So this is awesome. I'm excited about the whole thing and thank you, of course, to everyone who joined us and took time out of your day. So it's much appreciated. Please contact us. We're looking for problems to solve, and we have an amazing partner at Senzary that's going to help us do that. So, reach out and let's figure it all out together. Thank you, everyone.
Thank you so much for the opportunity.
Thank you, Eric. And thank you all for attending. So
Enjoyed very much and hope that everyone learned something and enjoyed the presentation.
yes, and we look forward to seeing you in our next webinar. Thank you so much. Have a great
All right.
day.
Bye.
Bye-bye.
Bye.